Saturn. Saturn's the second largest planet. It's also the second most visible. Saturn got its name because it's further out than Jupiter, and it's Saturn was the father of Jupiter back, I believe, in Greek mythology. Saturn looks a lot like Jupiter, except fainter. So instead of the bright reds and yellows and browns, you basically just have tan. Its orbit is actually 2 times that of Jupiter. So again, as you get further away from the sun, your orbit is getting bigger. It also has many moons, and of course, Saturn has the rings. Saturn's atmosphere. Again, not as colorful as Jupiter's, basically yellow and tan. Different versions of tan or beige. There's no spots or ovals that we can see. Doesn't mean they're not there. Okay, they do have storms, they're just a lot harder to see. So, just like Jupiter, Saturn is made up of hydrogen and helium. Now, if you look at the percents, they're a little bit different. Hydrogen is in the 90s, helium is only in the single digits. So, a smaller percent of helium. Why that is, we'll get to, but essentially what they think is happening is the helium is being condensed and then sinking, kind of like rain. There's other stuff in there like methane and ammonium. Yeah, so here's a comparison of the two atmospheres, Jupiter and then Saturn. You can see they both have the stratosphere, they both have a haze layer, they both have troposphere, they both have ammonia ice, they both have ammonia hydrosulfide ice, and they both got water. The only thing that looks a little bit different is the coloring. Right? And the temperature line is same shape, right? Now for Jupiter it goes from like 100 to 400, and Saturn it goes from 100 to 300. So, okay. But same basic shape. So basically Saturn and Jupiter, very, very similar. Okie dokie, so again, similar structure to Jupiter, little bit of a lower temperature, right? Because we said 400 versus 300. Cloud layers are exactly the same, haze exactly the same. So cloud layers go about 250 kilometers thick. So they're a little bit thicker than Jupiter. Same order, same stuff in them, just a little bit thicker. And we think that's because it has a weaker gravity, so the clouds can actually expand higher up. Weaker gravity makes sense because Saturn is a lot smaller than Jupiter. Alright, so the colors of Saturn's atmosphere are caused by what we think the colors of Jupiter are caused by. Some sort of interaction between the gases, some sort of interaction between UV light, something like that. There's not as many gaps in the clouds as there was in Jupiter. Here you can see like distinct top and bottoms. Here they kind of blend into one another. Okay. We can't see below the clouds, so we don't really know what's going on. Whereas with Jupiter, we were able to see that there's a little bit of gas below the clouds. So, like I said before, you can't see the storms on Saturn as easily as you can see them on Jupiter, but it doesn't mean that they're not there. So these are pictures of storms, just not in visible light, like infrared light, actually. So computer enhanced, blah, blah, blah. But you can see the storm. If you look at picture B, you can see the storms quite clearly in the northern hemisphere there. Hubble was able to spot some of the storms. The white spot that then turned into a nice cloud band, which I think might be what we're seeing in picture B there. Cassini spotted some more stormy bands, white color. Again, it might have something to do with the ammonia ice. We're not entirely sure. It could just be gas rising up to the cooler atmosphere. Anyways, the storms work very similar to the Great Red Spot. It's a giant hurricane, but not as long lasting.